Ratios. Ratios are a comparison of two numbers. And proportions are a comparison of two ratios. So what's a good fit for both of these items? Well, it actually sits in this symbol called a percent. What is a percent? Well, percent simply means it's a ratio, but it's a ratio that's per 100. And so when we talk about percents like 7%, well, what does that mean? Well, it means that 7% is actually a ratio 7 out of 100, which transforms into the decimal 0.07. And how we get the decimal from 7% is we just move the decimal point 2 places to the left. Now there's also a nice little proportion we use with percents, and that happens to be this. It's percent over 100 is equal to part of something over the whole. So the whole is 100%. Now the part could be smaller than 100%, bigger than 100%, but we use this proportion to solve percent problems. And so that's what we're going to look at here next. So the first thing I want to talk about is this. What if we have to do this? What if we have to find 1% of 800? Well, 1% of 800 is just the number 8. And how I can get that is I can think, okay, 800 divided by 100 is 8. Now, why did I divide by 100? Well, because there are 101% in 100%. I could also take a look at this. What is 10% of 800? Well, how many 10% do I need to make 100%? Well, I need 10 of them, because 10 times 10 is 100%. So if I divide 800 by 10, well, the answer to this is going to be 80. So really all I'm doing so far is moving the decimal point. And if we see that, well, 100% of 800, well, that is 800. And so didn't have to make any change there. So if I ask this question to you, well, what is 7% of 800? Some would go to their calculator right away, but you don't need to, because we know 1% is 8. And if I need 7%, that means I need 7 of those. So 8 times 7 gives us 56, and that is what 7% of 800 truly is. So let's move on. Let's use this percent proportion that we've got here. And so we're going to try to answer this question. What is 50% of 64? So let's go ahead and use the percent proportion here. We put the percent, which is 50, over 100. Now we've got to figure out where to put the 64. So where do we put the 64? Well, we put the 64 in the bottom because there's some key words like of 64. That tells us that 64 is the whole thing. So the part, or what we're looking for, is x. Well, we already learned that, hey, we can just cross multiply to solve this. So we could take 50 times 64 and take 100 times x, or we can see the relationship that 50 is half of 100, so what's half of 64? 32. So that's a quick way to get our answer for that one. The second one I want to show you is this. What percent is 10 of 500? Let's use the proportion. This time I don't know the percent. So I'm going to put an X where the percent is over 100. Now, is 10 of 500? 10 is the part, because it's got a word is with it, and 500 is the whole, that keyword of that helps us out there. So if we cross multiply on this one, well, we're going to have 500x, and 100 times 10 is 1,000. So when we divide both sides by 500, that's going to give us x is 2. Now, we're looking for a percent, so we just need to put a 2%. We don't have to move the decimal point here because it's 2 over 100, and so that indicates that we've already got the percent there. Final one. 5 is 10% of what number? So, percent proportion. We know the percent, it's 10 over 100. So 5 is 10% of what number? 5 is the part, x is the whole that we're looking for. So again, cross multiply. Gives us 10x is equal to 500. And we're dividing by 10. So x is going to turn out to be 50. That is the whole. Don't need a percent because we're not finding a percent. And so that's what we're going to do with those right there. So let's apply this percent theory. And let's apply it in some things that, well, we do when we spend our money all the time. Our first one, a pair of pants originally cost $30 and the new price is $24. What is the percent of change? Well, it was originally, that we see here, the original cost was $30. The new price is $24. So we have dropped by $6. Where did I get 6 from? Well, 30 minus 24 tells us we've dropped $6. So the percent of change. Well, we've dropped $6 out of the original 30. Now, there's a couple different ways in which we could do this. One way is we could set up the percent proportion. X over 100 is equal to 6 over the original price. Always going to use the original. And in doing so, in cross multiplying, we're going to get 600 is equal to 30x, and x is going to give us 20%. That's one way we could do this problem. There's another way, and that is to just take 6 and divide it by 30. Now, 6 divided by 30 turns out to be 0.2, which is, well, moving the decimal point 20%. So the percent proportion is effective here again. But anytime we want to find a percent, we can just divide and move a decimal and we've got it right away too. So our last example is a flash drive. Costs $9 and it's on sale for 20% off. Gotta like that. And the sales tax is 8%. What would the total cost of the flash drive be on sale with the tax? So let's kind of do this maybe the little bit longer way. Let's take and do this. We're going to take 9 and we're going to multiply it by 20%. And when I do that, I have a button on my calculator that is a percent key, possibly. The higher, or the graphing calculators, I should say, don't have the percent key. So 9 times 20% tells us that that's $1.80. And that's the discount. I'm going to write that, discount. Now, to find my new price, I'm going to take 9 minus the $1.80, and so the sale price is $7.20. Now, I've got to figure tax. So the way tax is figured, when you go to the store, it's the price you're going to pay times the sales tax percent, which in this case is 8%. So if I multiply, now here's where I'm going to have to round to near a cent from time to time. In this case I don't, it's 58 cents. So $7.20, and the tax is added on. This tells me I'm going to pay $7.78 to make this happen. Now, depending on the calculator you have, I'm going to take you through the same problem with some different steps. And I'm going to write them out for you. You're not going to see maybe each of the little specifics through here. You might see them up on screen, depending on what kind of calculator you have, but here we go. We're going to take 9, and we're going to subtract 20, and hit the percent key, and hit equals. And what that's going to give you is that's going to go ahead and give you, once you hit equals, it's going to give you the $7.20. That equal sign is going to take that 20% off. So now to that, we're going to add 8%. And after you hit the percent key, you're going to see the tax, but then when you hit equals, you're going to see the total, which is $7.78, and that's the final cost plus tax. So depending on the calculator you have, is how you can make that work. So I want to take you through, for the independent practice, I'm going to draw a line here. I'm going to give you a scenario here, and I want you to use your calculator and see if you can come up with the final price. Again, this is something that you work at a department store, grocery store, whatever it might be from time to time. Yeah, you would have to do this, and you'd have to know how your machine would figure it out. You'd have to know and understand if your machine is doing it correctly. And as a consumer, you want to make sure you're doing and can do this as well. So we have a shirt that costs $15. It's on sale for 25% off, and we know the tax is 9%. You can do this however you want to, but I'll tell you the final price here momentarily. Give it a try. Okay, so the answer is $12.26, final cost with tax. And so these are the steps: 15 minus 25%, then hit equals, that gives you 11 1/4, then plus 9% and hit equals, there's your final total. You should have seen the two numbers, $3.75 and $1.0125, which we'd have to round to the nearest penny to make that work. So ratios, proportions, percents, they all go together, and oh, what a wonderful joy they can be when we have sales and discounts. Makes things cheaper for us, but don't forget that tax that's going to add it on at the very end.